In this lesson, we're going to take a look at solving linear systems by graphing. All right, so what is a system of equations? Well, a system of equations is the solution to two or more equations. And the solution ends up being an ordered pair. It's in the xy coordinate. So how do I determine if an ordered pair is a solution? Well, we've got that ordered pair 0, -4. Remember that the first coordinate is the x, the second coordinate is the y. And so what we're going to do is we're going to plug it into both of these equations to see if it ends up working. So I'm going to plug in my 0. I have x plus y is equal to -4, and I have x is 0 plus my y, which is -4. Is that equal to -4? Well, 0 plus -4 is equal to -4, so we could say that -4 is equal to -4. So we know it works for this one. Then we have the equation x minus 5y is equal to 20. So I'm going to plug it in again. 0 minus 5 times -4, is that equal to 20? Well, -5 times -4 is equal to 20. So 20 is equal to 20. So we know that this is a solution to the system. So now we're going to try the point 3, 3. So we have 3, 3, and this is my x and this is my y. So let's go ahead and start it and plug it into this first equation. So we have 3 plus 2 times 3, and we're going to see if that's equal to 9. So we have 3 plus 6 is equal to 9, and we have 9 is equal to 9, and so we know it works for that one. So let's go ahead and we have to test it for the second one. We have 4 times 3 minus 3, and is that equal to 15? So is 12 minus 3 equal to 15? Well, 12 minus 3 is 9, and that is not equal to 15. And because it doesn't work for both of them, so as soon as you know that it doesn't work for one of them, you know that it's not going to be a solution, and you wouldn't have to test the second point. So this is not a solution. All right, so I have y is equal to 1/4 x minus 2, and y is equal to 2x plus 5. So we know for the first equation, we've got a slope of 1/4 and a y-intercept of -2. So if we're using the slope-intercept form, we're going to then start on the -2 on the y-intercept, and I'm going to do a 1/4 slope. I'm going to go up 1 over 4, and I'm going to just do this a couple times. I want to make sure, sometimes when I go backwards, I just want to make sure that I'm going to get a nice straight line, because we're looking for that point of intersection. So I have y is equal to 2x plus 5, and so I'm going to have a slope of 2 and a y-intercept of 5. So I'm going to start on the 5. And then I'm going up 2 over 1. Well, I'm going to back up. I'm going to go down to -1. Remember, two negatives end up making a positive. And just so I make sure that I'm going to run into the right line, and then when I have all my points, I'm going to then draw my line here. And notice where they're intersecting. These 2 points are intersecting. So they are intersecting at the -4, -3. So what that means is that this point, -4, -3, is a solution to both of these equations. And if we went ahead and just plugged in our x and y to both of the equations up top, they would be solutions, just like they were in the ones where we were testing them to see if they were solutions. All right, let's try the next one. And again, we're graphing these today using the slope and the y-intercept. And so let's go ahead, and our first equation, y is equal to -2x minus 1. Our slope is equal to -1, and let's just put that all over 1. our y-intercept is equal to -1. So let's start on the -1, and from there we're going to go down 1 over 1, and I'm just going to extend it a few times. I'm going to go up and over this way, just to make sure I get a nice straight line so that we can find that intersection. All right, and so now I'm going to graph the y is equal to x plus 3, so we're going to be up at the 3. I'm going to go up 1 over 1, and so let's back up some. Down 1, -1, down 1, -1, down 1, -1. All right, so now, so the point at which it's intersecting is right here, which is at -2, 1. Okay, remember we said that the solution of the system is a point at which they intersect. And if you went up top and you plugged in the -2, 1 to both of the equations up top, you'll see that they are solutions to both of them. All right, question number 3. Notice how both of these equations are not written in slope-intercept form. These are in standard form. And so I can do one of two things to graph these. I could either solve for y, or I could graph them using the intercepts. I'm going to take this one, and let's just solve this one for y. And then the second one, let's go ahead and graph that one using the intercepts. So to get the y all by itself, I'm going to minus the 2x on both sides. I have 4y is equal to 8 minus 2x. And then remember, we're going to divide by 4 here. And then I'm going to have y is equal to 2 minus 2 all over 4x. Or it could be -1 all over 2. It doesn't matter. So let's go ahead, and I'm going to start at the 2. And then I'm going to go down 2 over 4. And then I will draw my line. I'm going to try and draw it as straight as you can. All right, so for the second one, I'm going to go ahead and I'm going to graph this one using the intercepts. Remember to do the intercepts, that we're saying that the x and the y are zeros. So it's going to be where it's going to cross on the x and the y axis. So if I plug in a 0 here, that whole part goes away, and I've got -2y is equal to -10. So I'll divide by -2, and I get 5. All right, so now let's go ahead, and instead of plugging in the 0 for the x, we're going to plug in the 0 for the y. And then this whole part goes away, and I divide by 2, and I get -5. All right, so let's go ahead and graph this. I'm going to plot the 0, 5, walk 0, up 1, 2, 3, 4, 5. And I have -5, 0. And then I'm going to draw the line as straight as I can. Is -2, 3. All right, number 4, we have x is equal to 5 and y is equal to 4. So remember, these are the special ones that just have the one variable. They're the undefined or the 0 slope. Remember, when the x is equal to 5, it's going to go through the x-intercept, where in every case, x is going to be equal to 5. It can be nothing else but 5. And y is equal to 4. It's going to go through the y-intercept at the 4. And so in every case, y is equal to 4. And now let's find the point at which it intersects. And so this point intersects at 5, 4. So we know that the point of intersection, or the solution to both of these equations, is 5, 4. You can plug in here, 5 is equal to 5 for your x, and for your y, 4 is equal to 4. All right, so example number 3, how do I solve real-world systems by graphing? So David and Alec are comparing the international calling plans on their phones. On his plan, David pays $4 to just place a call and $1 for each minute. Where Alec makes international calls, he pays just $1 for the place a call, but he pays $2 for every minute. So we have David, and his equation is y is equal to, he's paying the $4 to place the call plus $1 for every minute. Where Alec is going to pay, he's going to pay $1 to make the call plus $2 for every minute. So for David, we're going to start on the 4 and go up 1 each time. And so then we'll have this straight line going like this. Where Alec is going to just pay the $1, but then he'll pay $2. And so notice how then we'll go up like this. And remember, these are the number of minutes, where this is the cost. So how long would it take for the cost to be the same? Well, notice that after 3 minutes, so it's intersecting at the 3, 7, which means that after 3 minutes, on both calls, or both plans, you're going to pay $7. And notice if I plugged in my y, which is 7, is that equal to 4 plus 1 times 3? Well, 1 times 3 is 3, plus 4 is equal to 7. And if I plugged it in down here, 7 is equal to 1 plus 2 times 3, and that equals 7 as well. So after 3 minutes, they're going to pay the same to make the calls. All right, so it costs $15 for a yearly membership to a movie club at a movie theater. A movie ticket costs $5 for club members and $10 for non-members. So for our members, they're going to pay that $15 membership fee, but then they're going to spend $5 for every movie. Where the non-members, they're not going to pay a membership fee, but they're just going to pay $10 every time they are renting a movie. All right, so let's graph these. And I think I'm going to go up by 5s here. So let's make this 1, 2, 3, 4, 5 that way, but let's make these 5, 10, 15, 20, 25, 30. All right, so we're going to start at the 15 and then go up 5 over 1, up 5 over 1, up 5, and that's going to continue in this direction like this. Where our non-members, they're not going to pay an initial fee. So at 0 movies, they're spending $0. So, but they're going to spend $10 every time they get a movie. All right, so this one's going to continue, and it's going to go in a straight line. I can't get these straight. But let's come right here, and it looks like right here is the place in which it intersects. It is at 3:30, meaning that after 3, this is the number of movies, and this is the cost. So after 3 movies, it's going to cost $30 for each instance. So if you're a member, it's going to cost after 3 times, it'll cost you $30. And after 3 times, the non-members are also going to spend $30. But if you'll notice that the non-members, that their rate of change is going up. So after 3 movies, you'll have spent more money being a non-member than you would have a member. So after how many rentals? We would say then 3. And it will have cost, so 3 movies, and it will have cost you $30. So in this lesson, we took a look at how to solve linear systems by graphing.